Hi everyone. So we spent the last videos looking at the Egyptians and their interest in star patterns in order to guide their planting seasons and to guide their religious holidays and their religious observances. And now we're going to look at how ancient people viewed the patterns of the sun and how that related to their planting seasons and their survival. And to do that, we have to look at how they viewed the world. And they viewed the world in a very specific way that is independently across the board, whether you're an Asian people, an American people from the Americas, Europeans, Africans, they all had this same viewpoint of the earth at the center of what's called a celestial sphere. And the celestial sphere looked at all of the stars in the night sky as being in a dome over them that had no difference in distance. So everything was on the dome that they saw in the night sky. Conversely, they realized that the sun was different, and they made a plan that the sun would go in another plane on this model. And the plane that I am looking at with my mouse is called the ecliptic. It is the apparent motion of the sun around the earth. Now, of course, this model is wrong, but just because the model is wrong, we don't have to throw out the baby with the bathwater. We can take the good things of this model, and in fact, we still use this first scientific model because the planetarium at CCM and every planetarium is essentially a celestial sphere. Just because the model is wrong doesn't mean we can't use parts of the model to look at and to communicate observations that we make and to study those observations a bit more. So in doing this, they recognized that the sun was a very different part that was away from the sphere, and the sun traveled in the south, to the south in the sky, and the sun traveled to the north in the sky on a yearly basis. This plane here, not the light blue plane, we'll discuss that later. This plane here is called the ecliptic. That sounds a lot like eclipse, and you'd be right. Those two are related, and we will get back to that later. This ecliptical plane was part of the celestial model, and that was figuring into the sun's movement that was noticed by ancient people. In fact, going back to 4,900 BC, long before Stonehenge, this newer model has been found in the past 5 or 6 years called Goseck Circle. It was found in Germany, a series of pits that were lined with timbers. And when the sunrise came in through this break in the timber walls, and when the sun set through another break in the timber walls, these Germanic people knew that this was the winter solstice. It became a planning mechanism for them to plan their food stores to get through the cold Germanic winter. So this winter solstice was a symbol to them that this was the shortest day of the year, and that days would get colder ahead, but days would also get longer. Much later is Stonehenge, which is much more familiar at 2750 BC, another megalith that represents the winter solstice when the sun rises between these two megalithic stanchions that are up. So watching the sun was very important to ancient peoples. Now, what is this solstice that they are looking for? The solstice comes from the Latin word sol and sistere, which means sun and to stand still. And on this ecliptic, they knew that there were 2 days in the year when the sun seems to stand still at its northernmost point in the sky and at its southernmost point in the sky. This is the winter solstice, the southernmost point in the sky. This is the northern solstice, the longest day of the year, and the northernmost point, the northernmost point in the sky in the northern hemisphere on June 21st. You know that the solstice is a celebrated time for light, like the winter solstice and the summer solstice. The winter solstice is the shortest day of the year because on this winter solstice day, the northern hemisphere gets less light. In fact, the North Pole is in total darkness on December 21st. Conversely, on the summer solstice in June, the North Pole is in complete sunshine and the sun never sets at the North Pole on the summer solstice. So these solstices are important to the seasons. You may think that the seasons are made up of the distance from the sun, and you would be wrong in that, because actually the sun is closest to the Earth is closest to the sun on December, right around January. There's a mark in there right around this area of the orbit, gets about 3 degrees closer to the sun due to the pull of other planets and other stars. And you might think that January would be very hot. Of course, it's not, but we are closest to the sun in January. And in fact, even the southern hemisphere, which has their summer during January, is not that hot because a 3-degree difference is not the pivotal issue here. In fact, the pivotal issues for seasons are, number one, the angle of attack of the sunlight, and number two, the number of daylight hours to a particular area. So let's talk about the northern hemisphere and the angle of attack. If the sun is directly over a particular spot, and in the summer solstice, the sun is directly over the Tropic of Cancer, which is right around Austin, Texas, right around Jacksonville, Florida. And those areas get very direct sunlight. In fact, what you're noticing here is a beam of light that has 342 watt meters, which is a unit of power. And when that shines directly overhead, that beam is very concentrated and powerful. When that beam is on an angle, that power gets dissipated over a larger area, so that the seasons are very reactive to this. Even though the North Pole will get 24 hours of sunlight on June 21st, it will not be the hottest place on Earth because the angle of the sun's rays will be on a very oblique angle and will be dissipated. And the angle of the sun's rays over the Tropic of Cancer around Jacksonville, around Austin, Texas, will be very direct, and those places will have a much warmer June 1st as a result of that. The number of daylight hours also plays into this. For instance, you now know that the North Pole in June will have 24 hours of sunlight. The sun will never set. And conversely, at the equator in June, you will have a sunrise and a sunset, and it'll be just about a 12-hour day because the sun doesn't move that far. It goes from the Tropic of Cancer to the north, over the equator to the Tropic of Capricorn on the southern hemisphere's summer solstice in January. So there's not that much variation at the equator, and all the days seem to stay right around 12 hours of the day. What I would say is that you can look at the hours of daylight, and you'll notice that on June 21st, the summer solstice, the more north you get, the longer that daylight is. And the more south you get, all the way down to Antarctica, there's very little sunlight on that day, because you're noting here that the Antarctic Circle is essentially in darkness for the full 24 hours. So the seasons are based on the angle of attack, and the angle of attack is based on the tilt of the axis and the number of daylight hours. They're both related to the tilt in the axis. In fact, here's a graphic of the midnight sun at the North Pole. In June and for months afterwards, there's very little darkness at the North Pole. I wanted to mention the equinox as well. The equinox is another set. If the solstice is January and June, the equinoxes are in the middle. They are in March and September. Equinoxes stands for equal night and equal day. It is the 2 days of the year where every single spot on Earth gets 12 hours of daylight and 12 hours of nighttime. From the North Pole to the South Pole, every single spot on Earth gets 12 hours of daylight. It is such an important time for planting and for harvesting spring and fall that the Mayans in 800 built a pyramid that highlighted this to farmers in the area. If you see down here, here's a serpent, and on 2 days of the year, both equinoxes, the sun plays down and slithers down here to create a really neat representation of a snake slithering down the pyramid. Watch the video, it's very cool. Those equinoxes, with the tilt of the Earth, you see this equal experience of daylight on the face of the Earth that is here. And you can imagine with the same tilt coming around, there's 12 hours of daylight on the vernal equinox as well. All right, that's the spring and fall season. Here are the dates. The concept of the celestial sphere is such that it's not perfect, but it does help us, and it's still used today in our planetariums, and we'll continue to use it in our course. See you on the next one.